big opportunity, especially in the Southeast, because the Southeast has, depending on how you define the Southeast, the South, has something like 40% of U.S. activity in the industrial sector. We've got a lot of heavy industry here, a lot of thermal production that could be used to take that waste heat and drive a generator. So we've done some work on that. I think Gary said it's not happening because it's so cheap. That maybe is part of it, but I think it's really not happening because of decoupling. I'm a policy wonk, so I'm always turning to what policy is broken. You know, if it's so cheap, why isn't it happening? I think it's not happening because utilities do not get a profit on the power that they purchase. They don't get if they don't own the assets, they're not putting any equity into the project. If they don't own the CHP system, they will not get a return on equity from that system. And it's a little bit the same in TVA land. I've been pushing this. Of course, we don't have profits or shareholders or, you know, we're not traded on the stock exchange, but we do have a debt, and we are concerned about revenues. The more revenues, the more we can buy down the debt. So it's a little bit the same thing. If we're not making the revenues, then we can't relieve the debt burden as quickly. So we're not as incentivized, except that I've been pushing. And we do have some good examples of success there. The Weyerhaeuser plant in Columbus, Mississippi, which is a pulp and paper plant, is selling its excess power back to TVA after a protracted agreement there. It's about 20 megawatts of excess power they have from a generator that they were actually going to retire because they had a big pulping operation, which makes most of the material for diapers across the U.S. And then they used to have a paper mill that produced the finished product, and that used a lot of the electricity that they produced on site. Well, when the paper mill went bankrupt, they ended up with too much generator capacity and 20 megawatts of excess power. So it was in their best interest. They had a lot of waste biomass that they could use, heat that would otherwise be wasted, and they were looking for somebody to buy that power, and logical place was TVA, and finally a deal was struck. But there's so many more opportunities for that. The reason that, besides it's being so cheap, one of the reasons I like combined heat and power is because it's also a job generator. So we've been dancing around this job story all morning, and everyone has said energy efficiency and renewables generate jobs. Well, here is how they generate jobs. The way that you look at job generation from an input-output approach is you look at how say $1 million of expenditure somewhere in the economy, say 1 million more natural gas is bought, or 1 million more electricity. And then you look at what sectors of the economy gain economic activity from that. Well, you have pipe fitters and contractors of various sorts, and you spread that, you distribute that across in most input-output models, it's something like 404 economic sectors. And you see the multiplication, so you now have more accountants, you need more insurance, and then those employees, they go home and they have more money, and they go and they buy more goods, so it filters through the economy. Well, if you take a look at the total impact of $1 million in CHP construction and installation, you get a return of 14 jobs. If you look at CHP operation and maintenance, non-fuel, you get 19.8 jobs. If you just look at increasing natural gas, 6 jobs, electricity, 6, coal and petroleum, 7, and respending of utility bill savings, 15. So the point here is that energy efficiency is labor intensive. You get a lot of jobs from it, unlike the capital intensive nature of power production. And and fuel production. So I wanted to try to explain that. It ends up that the investment in combined, so I was on a panel on this with the chairman of the Federal Energy Regulatory Commission at the time, John Wellinghoff, and Tom Kasten, who's a big name in this field. And I told him I want to make the point that CHP is so good, not just because of the jobs you get when you build a plant. Everybody loves to have a plant built in their county, you know. It's a real boost for the economy. But it's because after you have it in place, you're generating such cheap power that everyone's rates are going to go down. And now you have a whole array of bill savings across the economy, the residential, the commercial, all the other industrial consumers are going to face a better, lower electricity price because CHP is so inexpensive. And it's that impact that far outweighs the jobs created from the construction of this plant. That's just the drop in the bucket. It's what it does to the rest of the economy, making it so much more energy efficient. And so at the end of my webinar with them, Tom Kasten said to me, thanks for showing us how many jobs are created by building, when you build a CHP plant. I don't think I made my point at all. I hope you understood. There's now actually a term that's been created. It's called the DRIPE terms. That might help. Anyone heard of DRIPE? All right, what is it, Max?
It's about the reduction of demand.
Demand-Reduction-Induced Price Effect. DRIPE. Demand-Reduction-Induced Price Effect. If you reduce demand, you're going to reduce prices. I mean, that's sort of a natural, that's like an economic law. So if we can reduce demand for this electricity, we're going to drop prices and everyone will benefit. And more money will be spent in other places.